Good morning, everyone. Let's kick off the high availability meeting for the day. It's June 28th. So if we could get started, I guess I'll document the answer about the IP address for everyone else to hear. The IP address needed to sync information between two peers. And it looks like we'll be needing to use a unique IP address. And theoretically, it should be provided by BGP. So that's the answer I have for everyone today. And if Michael joins, maybe he can expand on that a bit. And I guess we can get started, Marian.
Yeah, okay, so I want to share the pull request to SAI with the proposal for SAI APIs. I want to go over all the attributes, and then if anyone has some comments. I saw one for now. So yeah, so this is the SAI APIs. They are still going into experimental directory until Dash will be mature enough. We're putting everything there. So here we define a set of attributes for an HA session so that two devices will be able to synchronize their state. Let's start with the first one. It's the administrative state, up or down. Quite simple. We decide when we want to actually start syncing. It's up to the controller. Second is the one that I had question about, the PR IP. This is the IP address that we will communicate our state with. Should be unique and available through the basically through the underlay routing. Next one, by the way, also let me go over the.
Marian, we did have Michael just join as well. So there were more questions about that unique IP. This would probably be a good time.
Yeah, hey guys. Yeah, the IP to initiate the peering. So there will be always two IPs, at least, for this kind of stuff. So basically, there is one IP that is each card will have a unique IP, which is basically to uniquely identify the card, and then this is the IP that will be used to initiate the peering, right? So, for example, one like card A will have one IP, card B will have the second IP, and those are the unique IPs that will be used to initiate the peering, right? And on top of it, there is also the IP that is announced over the BGP, which is the highly available IP, right? So one card will be announcing the same IP than the other card potentially.
Mm-hmm.
And those are completely different set of IPs, right?
Mm-hmm. Mm-hmm.
And the basically the BGP, the IP that is basically the highly available IP, this needs to be both IPv4 and IPv6, right? Because like underneath the underlay, we have some standard that underlay is using IPv4, for which basically the cards needs to announce this highly available IPv4 IP, this like virtual IP. And for the standards that are using IPv6, the cards needs to announce over the BGP also in addition the IPv6 highly available IP, right? And this is basically what datapad will be using. So datapad will be using basically those two highly available IPs that the cards will be advertised. And but then the cards also need to talk with each other using the unique IPs, and this is this separate set of IPs. We call them like management IPs, on which basically the card can be accessed and they can talk with each other on their own kind of like private range and this kind of stuff.
And this unique IP, it will be available in band, right? It's not the out of band management.
What do you mean in band versus out of band?
I mean, oh, actually, sorry, confusing with the switch, like the out of the management network. So yeah, okay. So thanks for clarifying. So this is the unique IP that will be used for establishing the session. This was the missing information that we had. Up till now, I assumed only the virtual IP. Okay, thanks.
The virtual will be the virtual IP is actually more than one, right? Because one will be the IPv4, one will be IPv6, because each scenario requires some scenarios requires IPv4, some scenarios requires IPv6 for the outer encap or the underlay.
Right. Yeah.
Michael, what we're doing here is reviewing the PR that Marian submitted to OpenCompute in the experimental area for the SAI APIs, just to catch you up.
Yeah.
Okay, awesome.
Marian, a clarifying question. So this header file here, hand-generated set of, let's say, administrative attributes, I would call them. And so these are going to be manually or handwritten. And then we'll have, in addition, the auto-generated, let's say, data plane headers, right, that get added to this. So they're additive. Is that correct?
Yeah.
I think we ought to explain that somewhere in our documentation, because it's not obvious to someone walking in here how this all merges together. So at some point we'll want to capture, hey, there's some hand-generated APIs that are administrative, and then there's the auto-generated ones, and they merge together into one composite set of dash APIs.
Right. Yeah. We will, as soon as we will have an agreement, we can merge this API, then I will have a pointer to it explaining that this was done manually. You're correct.
Okay, thank you.
All right. Yeah, so just to recap, what we have is the admin state, which is create and set. So we'll be able to change the state. Then the unique IP for the session. This is mandatory on create attribute, and it is create only. So basically, it will stay for that session.
Quick question, comment about the admin state. So the admin state is the one that we discussed was related to the role, is it? Role of master and slave in terms of syncing?
Role is a separate attribute, which is also optional. I'll get to it next. But admin state is just up or down. Either we are okay with starting the sync, or maybe we are pending some other input from the control plane and waiting for the session to be able to start the sync up. And the role is the next attribute, which is it is optional. It is create and set. So there was a question why we need backup role. So in case there will be a requirement that high availability takes priority over new connections. So we have two roles. So this is an enum. Let me go to it. We have two roles defined, active and backup. So active is the default one, meaning that you are kind of working independently from you can be working independently from a peer because you are active. So you can accept new connections if the operational state of the session is down, even if your peer is not available, because you can still accept new connections. And as soon as it will be available, they will be synced up. However, if someone desires to take high availability as a higher priority than new connections, then they can declare one of the peers as a backup, so that if the session goes down, backup will start receiving all of the existing flows that it will still forward as before. However, it will not accept new connections until there will be a new peer, and the session will go up again.
Can you define what session up and down mean?
Oh yeah, so this is the operational state. This is up to the implementation. This is this attribute. It's read-only. And there will be also an API with the notification of this state. But again, this is up to the implementation and the underlying protocol of choice. It means that the implementation decides that the peer is either available or not based on different criteria that will be chosen, either like heartbeat messages, or maybe there is like the feedback in case this is the reliable protocol that you get acknowledgements from your peer that you received everything. So this is then the implementation will consider, okay, our state is synced, and I can declare the operational state as up, meaning that any the judgment is that if now any flow would go to the peer, it will be properly forwarded.
Maybe we should define just session. By that you mean the inter-DPU peer-to-peer session, right?
HA session, meaning the peer-to-peer session.
So I have a clarification question on this, the operational state, right? Because one thing is the state of the peering, right? Whether a peering is established, is starting sync, is in process of the sync, or the sync is fully completed and is ready, right? And the second stuff is whether the peer is announcing BGP, right? Because the idea is that, for example, if let's say the one peer goes down, the peer goes up, right? It should be able to establish the peering relationship to sync all the connections, right? To be able kind of to prepare for being fully operational, right? And once the connection is fully synced, then there should be separate way to say, okay, now this peer is operational from the point of view of sync completed, and now I'm, let's say, okay to start announcing BGP back, right? Because one thing is that, for example, BGP should not be announced before we complete the sync, because if we start announcing BGP, that some of the connection in this active mode, right, may land on this new peer. The connections are not yet synced, right? So the peer would not know how to process this, right? So I want to basically separate two things. I want us to be able to separate bringing BGP up and down operational versus HS session that basically syncs the connections, right? Because like I would like to, for example, be able to sync the connections even if the BGP is not up, right? And this should be completely unrelated from bringing BGP up or down.
Right. So this is not related in any way to BGP. However, if we want more granularity, like saying, okay, those two can talk to each other, that's number one, and number two is that we have a fully synced flow table. Yeah, I will add an enum with more states, not only up or down.
Yeah, I would say that because the syncing definitely like the states of the state machine will be more, right? Because it'll be kind of like peer gets connected, right? Or it's like peer can be completely disconnected, right? Or peer can be connected, and then, for example, and then basically the state machine will go, let's say, starting syncing, or like sync in progress, right? And then, for example, sync completed and ready, and it's like ongoing sync, this kind of stuff, right? Because otherwise it's kind of like down versus up. It's not sufficient from the point of view of down. Means like down may mean that I'm not yet connected, but down may also mean that I'm not yet fully ready because not everything is synced, right? So definitely we need to differentiate the down from the point of view the connection can be established from something like there is a syncing in progress, but I don't have yet full state, fully sync to kind of bring basically the session fully up from the BGP. And then the third state that, for example, right now the state is fully sync and I'm ready and everything is syncing real time. So I basically the peer is fully ready with everything is synced from one side to the other. And this basically only means that this is the time when I can rise the BGP session up. So definitely more states here should be needed.
Yeah, of course. Understood.
I wonder if we ought to look at some existing.
So what does a peer mean? Is it a DPU peer or is it a ENI peer?
DPU. Well, granularity is on the ENI level, but the peer is a DPU, which is uniquely defined by the peer's IP address.
Yeah, but it's essentially you are pairing up the the ENI, why would you want to pair up the DPU?
So I would say like because one DPU will be handling, I think, like multiple ENIs, right? If we, for example, peer based on the ENIs, that means that one device will need to have multiple peers, right? So, for example, potentially like one ENI will peering with this ENI on the other DPU, this one on this kind of stuff. I really more think that we should establish something. Let's say that basically there will be something like a peering groups or peering sessions, this kind of stuff, and we can say that, for example, that at the beginning, that for example, device can only have, let's say, one peering session with those other cards, let's say, right? And those ENIs belongs to the peering session, right? So for example, this kind of stuff, because if we do the peering granularity based on the ENI, I think it may be too granular from the point of view, right? So because like if every single ENI can potentially land on like peer with complete different card, potentially yes, but at the same point, I'm more like thinking like it is designed here that's kind of like peering session, and this peering session has basically the list of ENI object to sync, right? Yeah.
Well, one could build the data model or the API to be generalized to accommodate such a sophisticated approach in the future. And then we all agree we're going to implement a peer one-to-one for the foreseeable future, but the data model won't prevent us from becoming more advanced if we choose to.
Yes. Yeah.
You know, that way we limit the scope of work, but we don't create a backwards compatibility or an API, you know, funkiness in the future. But that takes more work to even build in that roadmap. I'm wondering if some of these, you know, Christina actually mentioned this to me once in the past. Aren't there existing high availability architectures and things that we use every day, like Redis or other databases, other places where people have already kind of worked this out and agreed on the states and the synchronization mechanism and what can we draw inspiration from some of those things so we don't reinvent all the high level administrative things. It's just a thought.
Yay, Christina.
Like HK has been, you know, around since telecom days, and people have solved this problem about 1,000 times. And if we reinvent everything from scratch, we might be making more work for ourselves.
Yeah, I want to add to it. Yeah, we should definitely put as much as existing states it's possible as possible, right, to do this. And for me, the kind of like syncing mechanism, right, because the ENI is two folds, right? The ENI has like a goal state, which is the configuration, right, which is, for example, how ACLs looks like, how routes looks like for the specific ENI, and the routing policies, right? That's one thing. And the second thing is from the point of view of actual flows, right? And for me, the most important here would be really to design the synchronization to not have to sync the ENI state, which is the policy that our control plane can sync, and our control plane already has a way to basically send it to multiple peers, right? In normal distributed systems, kind of like eventual consistency, right? But the most important part will be to actually sync the flows, right? So I would like to use this HA session to really sync the flows and make sure the flows get synced, because that's I would say the heavy part, because it should be synced almost like real time or in batching, right? But from the point of view of the ENI state, which is the basically, let's say, entire ENI policy list of kind of mappings to translate this kind of stuff, that is that we can sync through control plane through eventual consistency. Because even if the customer, for example, update the ACLs, right? So for example, customer, let's say, switches one ACL and adds, for example, deny rule, this kind of stuff, right? They do expect that they will, that like once they click on portal, for example, to add some ACL, right? They do expect that, hey, this kind of new deny rule will happen in, let's say, 1 second, few seconds, this kind of stuff, right? They don't expect it fully in real time. So in this case, like eventual consistency, when we basically plumb this in specific location at some point, right? That normally happens, right? But the flow, this is, I would like to concentrate this kind of thinking mostly about the flows, because like once the connection is already established, right? Because the HA, literally the main thing is like if there is one device, right? If this device never dies, right, then we don't need to have HA, right? But the device may have power outage, this kind of stuff, right? And this is the one and the main reason why you need to have HA, that if one device dies for some reason or another, either networking problem or the power problem, or it's basically just hardware dies, right? Then the other device can take over, right? And for the other device to take over, right, the important part is, yeah, definitely the ACLs should be synced, right? But at the same point, they are being synced with eventual consistency, which means that basically within like few seconds, all the cards will have the same state, right? But most importantly, from the point of availability, right, if I initiate the connection and one device dies, then the connection should be on the other part. So I want to make sure that those are kind of two problems. And I would like us to first solve the problem of syncing flows, which is kind of important one, because syncing goal state for us is kind of like easy because the guarantees for the customers anyway, eventual consistency here.
Yeah, right. So this HA session is all about syncing flows. We are not looking at syncing the policies, because this is what controller will do.
Michael and Marianne, so when we look at the roles, right, the active and backup, if the two peers we discussed last time as well are sort of are learning. If there is a host, right, ENI, a VM sending flows, one of the two HA pairs will actually start to learn that, and that happens without the control from the controller or the DPU itself, right? So the active and the backup roles itself, when we assign, I see that what Gerald mentioned last time was that the BGP cost that it advertises for the two HA pairs to will be different, and the higher cost will become the backup and the lower cost will become active. I just feel that the role has a lot to do with the BGP configuration as well. And if a DPU comes up and the role is already active, and then if then another DPU partner comes up, right, which is also sort of equidistant from the VM, then the cost will have to be manipulated. So how does that work? What is your thought on that?
So Reshma, let me maybe add to it, right? So the stuff that you mentioned, the one is active, one is backup, and then one is announcing without ASN prepends, the other announcing with ASN prepends, right? This is the current implementation that we are trying in Azure, right? But at the same point, no one else in Azure, there's only one other solution that is using this, and this is huge. It causes huge impact on the control plane. Sorry, not control plane, like a physical network, because all this ISN prepends needs to be propagated with community strings, and it uses the TCAM space on the TORs, and it's basically not scalable to work with the active backup design. That's why basically what we are proposing here, considering that we are making new standard, to create this in a way that all the other services that we have in our platform, like for example, software load balancer, this kind of stuff, they actually have multiple instances which are announcing active. So there is no basically prepends or anything like this. They both basically announce. So basically, the two devices, for example, will come online. They will establish peering relationship between each other, saying that, hey, we are ready to receive traffic and this kind of stuff, right? And both will start announcing the VIP. And in this case, the physical network doesn't need to propagate communities and doesn't need to use TCAM space. They just basically announce the VIPs and they can be aggregated. And the traffic basically lands, the TORs will basically spread the traffic using normal like hashing algorithm, right? This kind of stuff. And some of the traffic will land, for example, let's say on this device, right? And if this traffic lands on this device basically will sync this flow to the per device. If some other traffic lands on the per device, this per device sync back to the first device. So there is availability, but there is no distinction from the point of view that one is strictly active and one is strictly passive, right? So we don't want to have, we potentially may want to have this distinction maybe as a, in case it's needed, but this is not really the primary mode of operation that we would like to use. So primary mode of operation, we actually would like to have bot devices advertise traffic without any ASN prepends. So the bot should be in the active mode, and it should not matter which receives the packets, the connections.
Right. So this is the
So-
intent, because attribute is optional, and by default, the peer should be considered active.
Default.
It should be a deliberate choice to put it as a backup.
And when it is backup, it is still active, right? It's just not. What is the exact definition when we call it backup?
Yes, as I said, the definition is in here. Backup is with regards to new connections. Does it accept new connections or not? Everything that was learned is still forwarded, but what do we do with the new connections? Do we want to actually learn new connections while we don't have another HA device to back us up, so that we are not synced to anyone for some period of time? Or we don't really care, we prefer to rather accept new connections and have the second device go up in the meantime, and that's why we would choose active. So backup is just not accepting new connections.
Yes, so this is not accepting new connections, right? I wonder from the implementation point of view, right? Because like we cannot advertise the VIP during this time, right? Because like if we advertise the VIP on the BGP on this card that has set up as a backup, right? Then all the packets will go to let's say to this backup device, right? And if there's not accepting connections, we kind of like black holing customer traffic, right? So that's why I'm more thinking that not accepting new connections should be more like separate stuff, that if I don't want to accept the connection, I just don't advertise the VIP on the BGP, right? This means basically not accepting new connections, right? Because if I will be advertising the VIP, but at the same point the role will be backup, this means I'm basically black holing the customer traffic in general.
Right, but if you want to achieve that with BGP, you can just put both into active and don't care at that point. But this is just a preference of whoever will be using that. We're just leaving this option, it may not be used.
If both advertise, then 50% of the capacity can be filled up with active connections, and 50% could be backup from the other side, for each HA pair. And those were the considerations I think we had earlier before we discussed this. So, is that still
just
the
use
plan?
Yeah, Michael, the description you just gave was real helpful. I'm wondering, to what extent does the existing high availability and scale README file in the Dash repo match what you just said, or has that become a little bit stale? It talks about longer paths, etc., and it doesn't. I don't know if it's
that's correct. Yeah, we need to update it, because this was created using like over a year I think ago, right? When we were the time where like we always wanted to have active, but the time basically it was deemed very hard to do this at the beginning, so that's why it's active passive, that's why it's proposed. But yeah, it should be updated. So Michael Melly, we should probably take an action item to potentially update this document, like copy this document as kind of like V1 and have a V2 version, which is the active version, saying that the connection should be actually active fully.
Right.
That's correct. That's a good observation.
I have a quick question. So for any given card, I mean the DPU, that DPU for any given time will act. Isn't it true that it will act active for some ENIs and will act as a backup for some other set of ENIs?
No, this is in the first design when we had this active backup, right? When only one card receives some specific traffic, right? But long term, we would like to have this basically fully active, which means that theoretically it should be active for all the ENIs.
Oh, so what you're saying is that when we talked about the scale part, right? When we said that, any given card will have, let's say, 32 ENI support, but those 32 will be active ENIs, and then there'll be 32 backup ENIs, right? Support.
Yeah. Yeah.
So,
Mhm.
so why when we made that point at that time, my basic understanding was is that the card will be, behaving as active for those 32 ENIs and will be behaving as a backup for the rest of the 32 ENIs, and thereby supporting 64 ENIs, and then you multiply the flows and connections and so forth accordingly. But now you're saying it's something different.
And so I would say like this. In my opinion, both modes of operation are actually uh, have some opportunities. Like in a way, for example, the active passive design is actually working right now, and it's kind of a interesting way of basically saying that one card is, for example, not receiving any traffic. The other card basically is receiving full traffic, that is basically doing this, right? And the reason why we have basically two set of ENIs per card is mostly from the point of view that we don't want one card to be completely dormant and connected to, for example, let's say gigabit network, but not receiving any traffic, because we are basically spending money for the capacity that is not being used, right? That's why in this active backup design, the proposal is that, because there's two things with regards to this flow replication, right? Because definitely flow replication in one direction, right, is theoretically easier than flow replication in both directions. If, for example, one packet lands here, the other packet lands there, right? So the in the active is slightly more complex than active passive, because active passive basically has always flow replicating in one way, right? But at the same point, because we don't want to have one card fully dormant, that's why we propose that if we are to stick with the active passive design, then at least have two groups per card, and one group basically will be active for one device and passive for the other device, but the other group of ENIs will be active for the another device and passive for the first device. So both cards are active at this like from the point of view of receiving traffic, but each receives traffic as the primary for a different set of cards, versus is a standby for a different set of ENIs, but a standby for a different set of ENIs, right? And this is mostly, the two groups is mostly to make sure we don't have like a card that is completely not utilized. So this was the only reason why we decided to have two groups instead of one group, because one in active passive, kind of, if you think about this, is always kind of like one card is active for ENIs, the other is standby. But in this case, the other card is completely not utilized. So that's why we decided to have two groups. So both cards are utilized. And in case one card dies, then the capacity of one card is halved, because this card is only serving traffic for both the ones that were active, plus the one that were potentially backup, which were right now is active. But it is still using the ASN prepend, right? So this interesting model, it works. And if you think from the point of view, if you actually implement active model, which means that once the ENIs are there, if the ENIs can receive traffic, it doesn't matter basically if the traffic from the Tor lands on the first card or the other card, it just instantly gets replicated to the mirror card, right? Then it's kind of the same replication. So once you have this replication, right, then the active is really the preferred one, because both cards are utilized this kind of stuff, right? And you can think that it is very easy once you have this flow replication working in both direction, irrespective when packet lands, right, to switch it in if active passive if you want, because switching to active passive is really the BGP configuration, right? So if we consider BGP configuration to be completely separate from the configuration of the flow sync, right? Then if the flow sync happens, right, irrespective of how BGP is advertised and redirects the traffic, right? If the flow sync happens when the packet lands, for example, on device A and it gets replicated to device B, or some other packets lands on device B and gets replicated to basically device A, and this works in both direction, right? Then we have active, which means the flow replication is fully working, right? And then doing this to active passive then doesn't require any changes to the sync algorithm. It just requires potential some adjustment to BGP. So I want to make sure that BGP logic, which is completely, for example, let's say separate microservice that is advertising BGP, right? This should be capable of advertising, for example, one card I'm advertising, let's say, without ASN prepend the same VIP, the other card with ASN prepend, and this will allow control plane of whoever will be using this to decide if they want to have active, which is the preferred way, right? Or they want to play with active passive or those kind of stuff, right? So that's why basically those are two kind of, whether we later do like active passive versus active active will be only depending on the BGP, right? But this is only on the condition, this will be only possible on the condition that the flow sync algorithm actually works in both direction, right? So because like if we design from day one to only support active passive design, then there will be lots of, for example, like shortcuts that will only sync flows in one direction and this kind of stuff, right? And we'll never be able to do active active. But really, the active active is kind of like a long-term vision, because this will allow us to save TCAM space, and this is also how other HA solutions are working.
Yeah, no, thank you, Michael. I think, it's based on, again, we are not precluding active, so, and it's a more flexible model. So even if we want to start with saying, hey, let's start to think about it only in the active passive part, but let's not preclude that, hey, we are not going to do, say, active. It's always, the understanding is that have more flexibility around it. And then that's why my question initial was, is that always think in terms of that, that we are pairing E and I, so as to not basically say that, hey, there will always be one-to-one mapping, so to speak. One card may be protecting ENIs from multiple different cards. So if that flexibility is there in the design or in the data model, then we are essentially really designing it for the more flexible and more scalable, sort of like more expandable design.
Yes. Yeah, and the design should be as scalable and as flexible as possible. Yes, that's correct, right? But one thing that I want to tell basically that, like, because we have TCAM space issues, because we know that like we are advertising lots of prefixes and this kind of stuff in data centers, right? We know for sure that we will not be able to put in a data center any new solution that is basically active passive only, right? Because like just ASN prepends scale in a very limited way, because they just need to be propagated everywhere. They cannot be aggregated, this kind of stuff, right? So even if we design some like prototype with active passive only, right, this will never be able to land in the data center. It needs to be active active in order to land in the data center, and in kind of like any scalable way.
So Michael, this is Suresh. Just to clarify, so the summary of what you're saying is whether a particular appliance is in active or passive mode is completely dependent on the BGP reachability to it, right?
That's correct.
So only the active would always receive, because it will have the lowest cost in the network, while the other peers within that peering group will keep receiving the flow sync, but they will never be responding, or they will have higher costs. So only one of them will be effectively active. There is no active passive otherwise. Is that correct?
Yes, that's correct. And one clarification on this, yeah. So you're right that basically it's just the BGP configuration, right? And just clarification on this, that in those cards or those devices that will be in data center, right? We want to actually set the BGP without ASN prepend, right? So the scenario that we are discussing right now, that will be advertising, for example, something with BGP as active, like lower cost, and the other as passive, as a smaller cost, like bigger cost, this kind of stuff, right? This is not how we configure BGP. Like, this is not how we will configure BGP, right? We may decide to maybe configure this in some like maybe edge side for the customer for some crazy reason, I don't know, right? But how we will basically configure those cards, I can tell you that we will get those cards, establish peering, and once the peering is sync, right, we will basically, both cards will advertise basically BGP with the same cost. So we will not be advertising BGP with different costs. It is nice to have this possibility, but we will not be doing this. Yeah.
Okay. Yeah, I wasn't quite familiar with the ASN prepend mechanism. I just read about it. I understand what you're saying.
Yeah, and let me maybe share quickly. I'm just checking if the slides have anything confidential or not. Probably not at this moment, so I can quickly potentially share it. This kind of what we kind of designed the project on our side is called Sirius. So it's kind of Sirius HA. It's kind of you guys should see that basically this is the kind of like pairing card replications, right? Which means that, for example, let's say there's one card, right, on one Sirius appliance that is paired with the other card on another Sirius appliance, right? And this kind of like vertical bars, which is kind of like, for example, the blue bar, green bar, this kind of stuff, that basically indicates one ENI, right? So in this case, ignore at the beginning the flow splitter. This is kind of like additional stuff that I can discuss in a second, right? But if you guys consider just only, for example, the most inner part, which is kind of the card that is basically pairwise replication with the red arrow, right? This basically means that basically this one card has, for example, let's say 4 ENIs of this kind of like blue, green, I think it's like teal and yellow, and the same goal state is basically on the other card, those kind stuff, right? And this card is basically has a pairwise replication, which means that the flow can here it's kind of like higher ASN and lower ASN, so it's kind of like slightly outdated. But imagine there will be no higher ASN and lower ASN. Basically, those will be advertising, let's say, the same VIPs. Like let's say this 23001 will be advertised by bot, for example, right? And then the traffic can actually land on any of those cards, right? And because these cards are pairing, they should basically replicate the flow to another card, right? So this is normal replication, and the reason why, and this is basically we want this to be working in active mode, right? So for example, if some VM1 will send some traffic, right? It should not matter if it lands on the card on the left series appliance or the card on the right series appliance, right? Wherever this traffic lands, from our perspective, it should be basically replicated with the other card, right? And this is, and we are thinking from the HA of kind of like enabling this in few steps, but at the end we want to have like a step 3 potentially, right? But the kind of step 1 and the milestone 1 will be kind of like have ENI on 2 cards. So basically program the same ENI on card 1 and card 2 from the goal state perspective, right? And don't establish yet the flow replication that we are talking about, right? So the flow replication, for example, there's no flow replication, right? So for example, just the goal state on both cards, right? And one will be, let's say, on the BGP, we'll configure that one is, for example, with a higher ASN, like lower ASN prepend, higher ASN prepend, this kind of stuff. And it's kind of this kind of backup, active backup, right? When we can potentially start testing those cards, this kind of stuff. But this also only guarantees for the customer the availability from the point of view of the goal state, but not from the point of the flow, right? So here you guys can imagine that like if one, because there's no flow replication, they can do milestone one, if one card dies, then the other card can pick up new connections because the ENI was configured, so the goal state was replicated by our control plane, right? But because there was no flow replication yet, all the connections will die for the customer, right? In case one card dies, right? So that's why, for example, milestone 1 is kind of good for testing, but not really for production, right? So we can test if 2 cards can basically support the traffic with this kind of like ASN failover, right? But there's no flow replication yet, right? The flow replication, actually, what we need here is what we are discussing is basically the step 2, which is the 2 cards, the same ENI is programmed on 2 cards. And we set up this pair for application, right? And we have this automatic BGP failover. In this case, the step 2 is kind of this automatic BGP failover. And here's like a active and no ASN prepends, right? In this case, right? So in this case, it's active. So both cards have the goal state and they set up the pairwise application, right? And if something fails, like connection fails, the BGP will take over and automatically, basically, all the connections will be going to only one card that's active. But because it was pairwise flow application was happening, that's why basically this card has all the connections. So there will be some few packets retransmit from the customer perspective to wait for the BGP convergence, which is like 5 or 10 seconds, this kind of stuff. Sure, unfortunate event, and during, however, no already established connection will get dropped. So for example, customer will experience some packet transmissions, right? If they were like transferring some bigger data from one VM to another or from storage, right? But no connection will be dropped because TCP expiration window will not hit, right? So in this case, the second solution is the one that we want to have, and is the one that we are designing, right? So basically, you want to have same ENI configure on both cards, and flow replication established using this, right? And using BGP that will automatically cover failover with this active-active mode, and no SAN prepends, right? And this is the one that you want to have, and it's the one that we are discussing, right? And in the long term, I can also tell you guys what we are planning to do, but it has nothing to do with your guys' implementation, right? We also want to potentially spread the traffic, because sometimes, and we call it kind of like infinite scale, but not really fully infinite scale. Like in a way, for example, if some customer, let's say one card will give, let's say, I don't know, like 4 million CPS, right? Which means that, for example, if we put ENI on this card, right, the customer can only reach, let's say, 4 million connection per second, right? And this is the upper limit on the card, right? However, we can actually do more intelligent hashing that right now the Tors can do. So the Tors basically normally do hashing based on like 5 tuple of the connection, right? But it still goes to the same VIP, this kind of stuff, right? We actually want to put the splitter, which is on the left side, and do more intelligent hashing, like in a way that based on this like consistent hashing of the connection that gets, from example, from the VM1, right? We will actually encap this traffic with this kind of tunnel, right? Not to the specific card, which is like pairwise replication with the red, but for example, for one of the other cards, which is also paired with the other cards. That's why those are additional cards, which is, for example, pairwise with a card that is pairwise with blue or green, right? And in this case, we will program the ENI on more than 2 cards, right? We'll program the ENI on, for example, all the 6 cards. Right, cards are paired. So basically, the innermost card, for example, is paired with the other card. The middle card is paired with some like other card with the same or different series of plans. Here, just 2 series of plans, but you guys can imagine that those cards can be wherever in data center, right? So, for example, in total, we'll have, let's say, 6 cards. Each of them will be paired. So would be paired. So, for example, in this case, we have like 3 cards here and 3 cards paired, right? And imagine that the same ENI is not only programmed on the main card and the paired card, but we program this on all the cards. So, for example, from the goal state perspective, right, all the cards will have the same goal state, so we'll be able to serve new connections, right? But all the cards will be advertising different set of VIPs. So, for example, the middle card will be advertising, let's say, this 23001 without prepends, right? The other card will be the other set of cards will be advertising 23002 without prepends, and the other card will be advertising 23003 without prepends, right? And then we have a splitter on the source side, closer to the VMs, which means that based on the 5 tuple hash of the connection, we'll decide, okay, this, let's say 1/3 of the connections that this VM originates goes to the specific VIP, which means that, for example, first set of cards, right? The other part of the connection goes to other set of VIPs, right? Which will be kind of doing the same kind of like ECMP is happening on the physical network, right? Just more intelligent from the point of view. It's not only doing ECMP on the layer 2, which is basically like this link versus this link, right? But or like basically like it will be doing on layer 3, which is basically the IP-based ECMP, so more intelligent. So this will allow us to even reach more capacity than the 4 million. For example, if one card gives us 4 million, right? Then theoretically, we can evenly split the flows that customer is experiencing, right? So one card will be handling, let's say, 1/3 of the flows, the other card 1/3. So we can have like 12 million CPS or even more if we spread the traffic evenly, this kind of stuff, right? And this assumes this active design between the cards, and it also decreases the blast radius, because if one card fails, only some part of the traffic gets affected, because basically the other card needs to handle all this traffic, but all this traffic only from the 1/3, right? So basically, we'll be doing stuff on our side, which is outside of basically this engagement, because this engagement mostly from the hardware perspective, right, to have replication between 2 cards. But on our side, we also will have the splitter, which will basically even split this ECMP based on the VIPs. And this kind of next step from our side. But for this, we need to have a step number 2, which is the flow replication, to make sure we provide availability between 2 cards. So the connections are not getting lost, right? So that's kind of how we are thinking about this, right? And this is how we can reach higher connection per second, even than like 4 million, this kind of stuff, right? Per card, right? And for the customer, so customer will be super happy about, I think, right? And this is kind of some of the IP addresses that we were kind of thinking from point of view of allocating that basically each card will have like unique address, which is for example, let's say for IPv4, maybe let's say 2/27. So each card, if we've for example 6 card per chassis in the risers, because this is how much space there is. For example, for some of the devices, this is what we will do, and we will allocate these unique addresses, right? And this will be, each card will have this like unique VIP. This is the one that is basically being advertised on the BGP, right? And potentially unique, really 128, but it's really advertised as /64 on Tors, right? So this kind of stuff, plus some additional management IP for the like management network, right? So basically the unique IPs which are here, right? And potentially the data plane IP, which are those, right? And those unique IPs are coming from like management network. Those are the unique, right? And those are those kind of VIPs. So that's basically this.
Thank you, Michael. This is really useful and very good to see.
Yeah.
One question I have is that when you split the number of flows between 3 sets here, right? Will it be based on the capacity of the DPU, and that has to be not full capacity, it has to be like 50% capacity, right?
So to be honest, like the splitting, right? It's doing basic splitting kind of like ECMP. So we'll not be doing any intelligent monitoring of the DPU capacity, this kind of stuff, right? We are assuming that flows, the splitting algorithm we'll have will be uniformly distributed, right? So we'll uniformly basically split the flow. So let's say 1/3 of the flow or 1/4, depending how many VIPs you will decide to split, right? We'll be doing this. So this will be like uniformly distributed. So definitely not intelligent. Maybe in the future, but I don't perceive this happening. Right. At the same point, the splitting, I would say it's outside of our discussion for the HA, because this plus even more fancy logic that we have on our side, we can do with the HA once we have the basic HA functionality of the flow replication between two cards, and this is basically the main idea of this work stream, to make sure that this point number 2, which is basically we can put the same ENI on 2 cards, have flow replication, right? And then on top of this, use BGP for failover. That's the main goal, right? So anything else, like the first thing is mostly like we are doing some internal testing, whatever, not really related to this kind of stuff. That's the second stuff is really where we need this work stream to kind of give the cards ability to do flow replication, so the customer connections are not being affected, and the ECMP is really like internal stuff. We right now are doing this like just normal ECMP, just using the layer 3, right? But we can, the splitter can be even like more complex or whatever, right? But this is outside of this workstream, right? So this workstream, I want to make sure we only discuss how we solve the flow replication in both directions to make sure we can support active.
Well, guys, we have 4 minutes left. I'm wondering if this is a good stopping point. Marian has left the building. And does everyone else feel like we have what we need for this session? I don't think we got through the full set of APIs. We may have to pick up where we left off next week. Does anyone have a comment before we drop off? I guess I will take silence as agreement. Michael, thank you for coming, and thank you for explaining everything in more detail. Appreciate it.
Yep. Thanks, Michael.
Thank you, Michael. Yeah.
Thanks, guys.
Okay, everybody have a good week. I'm going to stop the recording and I'll place it onto YouTube